It's always possible to push the limits and to take it further.
It's not invented overnight. It kind of stands on the shoulders of our legacy and all the insights that we have gained over years.
With intent, the speaker unit is new, the hearing aid is new, and the charger is new. So that is 3 rather large development projects that worked in parallel, but that need to work together as a solution.
We made some early investigations. Could we actually use body and head movement and other detectors to improve the life of the hearing impaired and make it better? And yes, we realized there are differences in the way the body and head moves when you are in a single talker conversation or when you are in a multi-talker conversation.
There's so many steps and it's so exciting to go through all this, and ultimately the idea is to make something that counts.
The basic thing is to build the system that can do the kind of processing, the detection mechanisms using the 4D sensor technology. And then the other thing is to make it work in a way where it really makes a difference in real life.
And it's a new way of thinking sensors into hearing instruments, making the hearing instrument more clever about the intent of the end user and the different contexts that they want to use the hearing aid in.
What the sensors provide is inputs in the context of what the user is doing.
We ended up actually working without telling the users anything about it, because what we really wanted was a system that was solid and that would work when people use it without them changing behavior.
It might not be visible from a first eye. If you compare an instrument from the intent instrument and with the previous version, I mean, you can say, I mean, they look quite similar. But the integration of the new connectivity and features in it, it's miles away. This device consists of thousands of parts, and these parts take space. So it's not just only kind of like, here's a grab of a handful of sensor, just put them somewhere. Nope. They have a very specific place and function, so everything is calculated to the very little extent.
It requires teamwork, requires hard work together, and a lot of people have contributed to this, and that I'm proud of.
The sound experience is on a completely new level. The user experience is amazing. I would say it's really a huge step in our product development.
Now when we're sitting at the end of the table or the road, I mean, I can say that it was a huge fun. Was I stressed? I mean, was it difficult? Pretty much. But we made it.
Good morning, everyone. Thank you for joining us today. My name is Gabriella, and I am the corporate trainer at Demand South Africa. As most of you know, we launched our hearing aid, the Oticon Intent, with the latest technology in February this year. With this launch, we now introduce new products that ensure additional convenience for our users, as well as new evidence that document the benefits of our groundbreaking audiology in the Intent hearing aids and what this cutting-edge technology offers your patients. In H2 2024, we introduce new brain hearing evidence that shows a reduced listening effort and, as an industry first, reduced listening stress. In addition, we document in a realistic test setup the Oticon Intent versus 4 competitors in complex listening situations. We've also got a smart charger that allows Oticon Intent users to charge their hearing aids while on the go, as well as new fitting tools that optimize clinical efficiency. So let's start by zooming in on the brain hearing evidence. At Oticon, we recognize the brain's exceptional sound processing abilities. We have a unique understanding of hearing loss, and we call this philosophy brain hearing. It means that we understand and support the brain's natural way of making sense of sound. And it means we continuously explore new ways to help the brain create more meaning with less effort, so that people can engage in life like never before. So how do we give hearing aid users the energy to live the life that they want? And this is a question we've been asking ourselves for years. To find the answer, we've taken a unique path with our brain hearing philosophy and open sound approach that no other hearing solution can offer or match. We started this journey in 2016 with the introduction of the Open Sound Navigator. And when we introduced the Oticon Open, it was the very first innovative hearing aid based on our open sound technology. Since then, with the launch of the Oticon More and subsequent hearing aids, we've also advanced the use of artificial intelligence and deep neural networks in our hearing aids that take the open sound experience and documented benefits way ahead of traditional technology. For years, the hearing aid industry has strived to improve speech understanding and noise for people with a hearing loss. And most manufacturers have done this by applying a combination of aggressive front-facing directionality as well as aggressive noise reduction that makes all other sounds inaudible to users. At Oticon, we understand that the user's most important need is to improve their speech understanding. However, we also understand that users don't like aggressive noise reduction that deprives them from understanding the environment they are in. Access to all sounds throughout the day is to access the life that is lived all around you. And Oticon has been gathering evidence for more than 30 years, building knowledge step by step on how to create hearing solutions. You could say that the pinnacle of this has been to use all our knowledge in training the deep neural networks to create the best open sound AI available that creates a clear and precise rendering of sound that fits your patient's unique needs. All competitive offerings or traditional technology is still built on directionality, and Oticon is still the only solution that supports users with a true open sound experience throughout the entire day in any given situation. To support our innovations and remain at the forefront of cognitive hearing research, we continuously develop our research and testing methods in collaboration with leading researchers. At Oticon, we have an open and curious mindset in terms of developing innovations that support the brain, but also in the way we design and conduct our research. We are continuously trying to push the boundaries of our hearing technology and improve the lives of people living with hearing loss. So to prove the incredible benefits of the Oticon Intent with the groundbreaking 4D sensor technology, we've put it to the test in dynamic real-life scenario listening environments, and we use innovative research methods such as EEG testing, VR technology in an advanced audiovisual immersion lab, and pupillometry and pulse monitoring devices. Going above and beyond the competition when conducting research is our way of developing the life-changing technology of tomorrow and proving with confidence that Oticon Intent with sensor-driven brain hearing technology works today. So let's have a closer look at the Oticon Intent technology and the latest evidence behind these remarkable hearing aids. If we consider the listener in this picture, what is important for a hearing aid user in a situation like this one? Hearing and understanding speech despite the noise seems like the obvious answer. Understanding speech in a noisy setting is actually the #1 challenge for people with a hearing loss. However, we need to enable them to do this without being completely exhausted afterwards. And it is well known that listening in noise requires cognitive effort. So the brain works hard to pull the speech out of the noise to make meaning of it. But cognitive capacity is finite. We only have so much of it. And if we use it all on listening, we have less capacity for other tasks. When creating hearing solutions, we need to ensure that they support the user's brain optimally so that they can focus their capacity on engaging in life. And the Oticon Intent aims to do exactly that. Oticon Intent, with sensor-driven brain hearing technology, supports people with hearing loss so they can engage in life like never before. As we know already, it features groundbreaking 4D sensor technology, which is a unique new technology that allows the hearing aid to recognize the user's listening intentions and then adapt accordingly. It's the industry's first hearing aid with user intent sensors. So, building on insights from research on communication behavior, Oticon Intent combines the 4 following types of sensors into understanding and acting on the user's listening needs. The first sensor is the conversation activity sensor, which monitors if there is an active conversation or not and informs the system to prioritize speech. The head movement sensor monitors if and how the user moves their head to understand the type of communication. Body movement or physical movement sensors help anticipate the need for increased spatial awareness support. And finally, the acoustic environment sensors gather details of this 360-degree sound scene around the listener. And this means that the devices go beyond just taking into account the acoustic environment, and users get more personalized support based on how they behave in a situation. So with traditional technology, the level of support that a hearing aid user will receive in a noisy environment will be the same, regardless of what they're doing and what their goals are in the situation. So the 7 pictures along this graph refers to different activities that a person might undertake at a social event. For example, walking in the room, chatting with a group of friends, or having an intimate conversation. The level of support offered by traditional technology is based on an acoustic analysis of the sound scene and hence will remain fixed for this given environment, no matter whether the user is walking or having an intimate conversation. However, in a busy restaurant, a guest conversing with a friend may face the same acoustic complexity as the waiter who's walking between the tables, but their listening needs differ greatly. While the guest primarily needs support to understand what their friend is saying, the waiter may benefit from enhanced awareness of the surrounding environment. The level of support offered by Oticon Intent with the 4D sensors adapts based on the listener's intent in the situation. So whether the user is navigating the route, needs more awareness of the surroundings, or whether the user is engaged in an intimate conversation, Oticon Intent offers the right support. And as Oticon Intent adapts to the listening intentions, the users will experience an adaptation of support that spans a 5 dB output SNR even within a single environment. So we already have an extensive package that supports Oticon Intent and documents the benefits of using the sensor technology. We know that it provides seamless adaptation of support even within the same environment, and that there is a 15% improvement in speech comprehension with the 4D sensors technology off versus on. It supports the brain and outperforms Oticon Real, our last premium hearing aid, by providing 35% more access to speech cues, as well as better sound quality, more nuances, and a higher listening comfort. However, we wanted to take our research further. We wanted to investigate how it feels to be in a challenging situation while wearing the Oticon Intent. One thing is having more access to speech and having better speech understanding. But how much effort does the individual need to put into this? And how stressful does it feel? We are constantly surrounded by all kinds of sounds, but it is often in loud, distracting, or complex sound environments when we start to feel the negative effects. Noise can also be uncomfortable, and this is reflected as stress response in the body. We know this from research, but it has never been formally investigated with how hearing aids influence stress levels until now. In order to document the positive effects of Oticon intent on the listening stress and listening effort put into listening in noise, we conducted a research project in cooperation with the Technical University of Denmark and the Eriksholm Research Center. We wanted to create a realistic test environment, ensuring that the results reflected real life. This required advanced test methodologies, one of them never seen in the industry before. We used a novel experimental approach with virtual reality, where participants moved to locate a target talker and then solved a speech comprehension task. Some of you may have had a similar virtual reality experience with the VR goggles that your Oticon sales reps use to demonstrate the benefits of the Oticon intent. So for this experiment, we used two objective outcome measures: objective listening effort, which is often assessed through pupillometry, and listening stress. Listening stress can be assessed by changes in the heart rate in response to variations in the listening environment. An elevated heart rate indicates higher stress levels, which may reduce available cognitive resources. Note that measuring listening stress in people with hearing loss and hearing aid users is an industry first. So with these two measures, we could gain insights on how the use of cognitive abilities is reflected in the body during an active listening task. But first, what defines listening effort? We've said that listening effort is a specific form of mental effort that is exerted when a task involves listening. So objective listening effort, as we've said, is typically measured using pupillometry, which involves continuously recording a listener's pupil dilation while performing a listening task. And when performing a demanding task, such as listening to speech and noise, an increase in effort is reflected by the change in the pupil size. The larger the degree of pupil dilation, the more the listening effort is thought to be needed for the task. In studies investigating listening effort, short sentences are typically used as speech material in the listening task. However, this may not fully represent real-life listening situations because we often listen to running or continuous speech rather than isolated sentences in everyday conversation. Following a conversation requires paying attention to the talker over a sustained period, which is known as sustained attention and staying engaged. Now, by assessing the change in pupil dilation while listening to running speech uses a longer time window, and it gives us a measure of listening effort that is more representative of the real-life listening situations. So the aim of this part of the study was to measure and compare sustained listening effort with and without hearing aids by means of pupillometry. In other words, will people be able to stay engaged in a conversation for a longer period of time? But we also looked at another aspect of how the test participants reacted in the test environment. We looked at their stress levels. Listening stress is a specific form of stress experienced when a task involves active listening in noise. It is linked to listening effort because increased effort caused by the presence of noise can lead to stress. Listening stress reduces our ability to engage in conversation. Stress is a natural response to perceived threat, and during periods of stress, our bodies trigger a fight or flight response in order to increase our chances of survival, and this raises our heart rate. Dealing with loud noises and struggling to follow speech in noisy environments can cause the same reaction. Studies show that even short periods of stress can have a negative impact on our cognitive abilities, which reduces our ability to engage in conversations. Now, by reducing the impact of noise on the user's cognitive abilities, we expect to see a reduction in listening stress. And this can help users feel more engaged during conversations in challenging listening environments. Since changes in heart rate can be observed as a reaction to listening in noise, heart rate monitoring was used as a method in this study. The change in heart rate could give us insights regarding the levels of stress in varying realistic listening environments that the test participants were experiencing, and as a result, determine if people have cognitive resources available to engage in situations. Now, previous research has only been focused on people with normal hearing. Using heart rate as an outcome measure in people wearing hearing aids has never been done before. So using virtual reality technology, realistic scenarios were reconstructed with simultaneous conversation and background noise. And here the participants were free to move their heads and bodies to identify and understand one talker amongst others, just as they would in real life. Now, this approach is noteworthy because it allows and encourages the test participants to move, just like they would in real life. In a typical test setup, the participants would sit still facing the front. And this means that we could investigate the effect of the 4D sensor technology and the Deep Neural Network 2.0 on speech comprehension and objective listening effort in a realistic dynamic sound scene. In other words, we know that people move in different ways, and we wanted to test the effect of our device being able to take this into account. The objective of this research was to investigate the effect of Oticon intent on objective listening effort and stress in a realistic, dynamic, and complex sound scene. And this experiment was documented and will be shared in the next video.
With Oticon Intent, our users will have more cognitive capacities available so they can engage in life without feeling exhausted at the end of the day. My name is Valentina Zapata Rodriguez. I am a senior researcher at Oticon. For me, as a researcher, the most interesting part of this study was the evaluation of listening stress. We know from the literature that noise actually can affect heart rate. So when we go into a noisy environment, our heart rate can actually increase, and this is connected to listening stress. So we are perceiving more stress due to the change in the sound environment. But this has never been before tested with hearing impaired users, or actually the effect of the hearing aids on listening stress. In this study, we put a lot of effort into designing a listening test that was closer to reality. So we wanted to increase the link between naturalistic testing in our lab. So then to do that, we collaborated with the Technical University of Denmark and the Ericsson Research Center. And what we did was to use virtual reality and room acoustic simulation to simulate a typical listening scenario, being at a party or like a dinner where you have multiple concurrent conversations happening at the same time. So the participants, what they have to do was first to locate a specific story, that it was coming from a visual avatar that they could see on the goggles, the VR goggles. And then once the participants locate the avatar, so they had to stay still, and then now they will hear a news clip. And then they needed to stay still paying attention to this news clip, and then at the end of the news clip, they will answer a question about the content. So then this is similar to the common listening scenario, right? So then you locate and then you pay attention to the conversation, this intimate conversation that is happening. Also, with this setup, what we wanted was actually to test Oticon Intent, how the user will use it in daily life. In this experiment, for us was very important that the users could actually move. So then it was closer to the dynamic that we actually encounter in real life, like in conversation. And the results were remarkable. So we found a significant reduction of up to 31% on listening effort based on the relative change in the mean pupil dilation. And also, we found a reduction of 40% in the mean change in heart rate. And with this monitoring heart rate, we evaluated the listening stress. So for our user, these results means that Oticon Intent provides personalized listening support that supports the brain by reducing listening effort and listening stress, so our users can have more cognitive capacities available to do other things during the day and engage in life like never before.
All right, let's review those remarkable results again. The study was conducted in a very challenging environment, which included multiple speakers. And the evidence shows that Oticon Intent users experience a 31% reduction in sustained listening effort. By understanding the user's intentions, Oticon Intent seamlessly and automatically optimizes the amount of listening support to prioritize speech. And this allows users to remain engaged in group and intimate conversations, even in challenging environments, with less effort for sustained periods of time. And all while staying open to the 360-degree sound scene around them. To measure listening stress, study participants were asked to complete challenging listening tasks in a complex listening environment while wearing a heart rate monitor. The results from the heart rate measures show the average change in heart rate between the complex and very complex sound scene over the course of the speech comprehension task. Even in the most stressful listening situation, Oticon Intent instantly reacts to the user's needs, delivering a 40% reduction in listening stress compared to our best previous hearing aid. And by reducing the impact of noise on the user's cognitive abilities, we see an incredible reduction in listening stress, which can help users feel more engaged during conversations in challenging listening environments. So what can we conclude from this? Increased support in noise with Oticon Intent and 4D sensor technology leads to significant reductions in listening effort and listening stress seen by pupil dilation and reduced heart rate changes respectively. Oticon Intent frees up cognitive resource to engage in life and do the things that people want to do without feeling limited by their hearing loss. Next, we'll have a look at the evidence that shows how the Oticon Intent compares to 4 premium brands. Spoiler alert, Oticon outperforms the competition. But please keep watching, even though you know how the story ends now. I'm sure it'll still be worth your while. So before we get into the research, let's quickly recap how hearing aid technology supports users. The hearing aid industry has come a long way in terms of delivering a signal processing to deal with challenging listening environments. The most common way is directionality algorithms, which are based on the assumption that the hearing aid user is facing what they want to hear and turn their back to the noise. In other words, speech of interest is at the front and disturbing noise is behind. In this case scenario, traditional directionality is likely to be effective. This is because the processing in hearing aids is geared towards enhancing front-facing speech and reducing noise from other directions. So the speech of interest will fall within the directionality beam and the noise will be outside it. However, this is not what the user will meet in the real world. In complex real-life environments, noise may come not only from behind, but from other directions, including the front. And this means that in order to support hearing aid users, another strategy is required. We need a strategy that can address noise regardless of the direction and preserve the speech the person intends to hear. And Oticon Intent does exactly that. So in addition to the 4D sensor technology, Oticon Intent features a new second generation deep neural network 2.0. Now, neural networks are a specific class of algorithms under the more general discipline of machine learning. The idea of machine learning is to take a large amount of data, known as training samples, and then develop a system which can learn from them. The uniqueness of neural networks stem from their architecture similar to the brain. And this advanced technology drives a hearing aid that works more like the brain because it has learned through experience. And this enables a better and more accurate representation of sound in the brain and better access to sounds all around the hearing aid user. But how is the DNN trained? It is provided with a target output that it tries to match. So in this case, we're trying to match the bird sound. If it does not match, for example, in the case with the elephant, it tries again. And this way, the learning is based on trial and error. It may be that parts of the sound scenes are processed correctly and other parts somehow misrepresented. And this will also be fed back so that the continued learning can focus on getting the output more and more optimized. The deep neural network is not trained on single sounds, such as in this conceptual example. It's trained on complete sound scenes as we would encounter them in real life. The sound scenes consist of small clips of a sound scene with sounds coming and going, including recordings of all the details from the surroundings. So, how does the deep neural network learn to handle a sound scene in real life? Processing sounds correctly, especially in complex listening environments, like the one shown here, is a complex task for a hearing aid. Sounds are mixed together, coming and going, and some sounds are even constantly moving. The deep neural network is trained with millions of real-life sound scenes. And this way, it can learn to recognize different types of sound and their relative importance. A deep neural network consists of different layers, composed from a number of neurons with many connections. Each layer feeds information in one direction from input to output. The neural network does not see a sound scene. It receives a complicated mixture of sounds. In the case of a sound scene, the first layer extracts the simple sound elements and patterns from the input. Then the next layer builds these elements together to recognize and make sense of what is happening. And finally, based on all of this, the output layer chooses how to balance the sound scene. And this is then compared to how it should ideally sound. At first, the neural network has no idea what it's listening to. It only hears a complicated mixture of sounds, so it just responds randomly. But every time it balances the sound scene the wrong way, the information flows back through the network saying, no, the balancing is wrong. So anything that was supporting the decision, the connection becomes weaker, and anything that was supporting a more ideal balancing, the connection strengthens. Now, since this is a supervised learning, the deep neural network is informed about whether or not it has made a mistake and whether or not it should change. And how do we know when to finalize the training? As humans, our learning slows down as we grow. But what about the deep neural network? The deep neural network is trained to recognize meaningful sounds. The definitions of these sounds must be just right. Not too broad, not too narrow. If the training continues for too long, i.e. overtraining, the definitions could become too narrow, and in this case, sounds may not be processed optimally. And this is the reason for the training being completed at the Oticon development facilities. Please take special note here. Unlike other DNNs, the reason why the training does not continue in real life as the user wears the devices is because this could result in overtraining. Additionally, the deep neural network training requires feedback to the system. In the real world, there is nobody to tell the system what's right and what's wrong and give priority. So for this reason, the training of the deep neural network is carefully and thoroughly completed at Oticon HQ. When the training is completed, it is transferred to the Sirius chipset, which is implemented in Oticon Intent. Now, as I've already mentioned, the DNN in the Oticon Intent hearing aid is a second generation DNN. We launched the industry's first ever embedded DNN in the Oticon More in 2021. Since then, the new DNN 2.0 builds upon the knowledge and the insights from our first generation DNN to once again push the boundaries of what is possible, providing even more benefit for hearing aid users. After the first DNN was trained on 12 million sound scenes recorded in the real world, an even greater diversity of sound samples was used to train the DNN 2.0. Most are challenging and complex, so the DNN has learned even better strategies for real-world complex environments. By adding higher demands on the performance on the DNN in the training phase and running the performance analysis in 256 channels compared to only 24 channels for the first generation DNN, the output of the DNN becomes more precise. And this result is a DNN that produces a cleaner and more precise representation of the original sound. Secondly, DNN 2.0 has also become better at preserving the original sound, which means less loss of cues for both speech and noise. And because of this, the system can suppress unwanted sounds by up to 12 dB in complex environments, which is 2 dB more than previously. All the while remaining sounds are clearer and less distorted. And this results in a better signal-to-noise ratio, providing better clarity and a much better listening experience with less disturbance. And thirdly, something that we should not forget is that the DNN is always active. It's not limited to a program, and it does not require activating from your patient or deactivating it. You can rest assured that your clients have constant access to the full sound scene. So remember, folks, no matter what other people tell you when it comes to DNNs, it's not the size that matters, it's how well it was trained and how it's used. The deep neural network in Oticon Intent enables the sounds of the world to be handled precisely and automatically. And this optimizes the way More Sound Intelligence 3.0 makes sounds more distinct, working seamlessly across various listening environments. With this integrated intelligence, More Sound Intelligence has learned to recognize all types of sounds, their details, and how they should ideally sound, all in order to optimally support the brain. With these technologies, Oticon Intent provides a superior starting point for helping hearing aid users do well when the environment becomes challenging. The system adapts constantly and fluidly to the environment up to 500 times per second, whereas traditional directional systems are based on either switching between different modes or simply an on and off behavior. Traditional systems are typically slow and do not adapt immediately when the environment changes. The Oticon Intent adapts with the environment as conditions around the user change. And traditional technology uses beamforming that disconnects the user from the surroundings, whereas Oticon Intent is open to all sounds with the aim for allowing engagement and participation. But the big question is, does it really work? So to document that Oticon Intent outperforms other strategies, we conducted a systematic technical evaluation of Oticon Intent and 4 leading competitor brands. Our goal was to compare the devices fairly in terms of their ability to enhance speech clarity and access to speech cues when speech and noise are both coming from the front. Now, to do this, we recreated a realistic, busy, noisy sound scene with diffuse noise, whereas a typical test setup would have speech from the front and noise from the back, but that does not represent real life. The purpose of the study was to investigate the support provided by Oticon Intent compared to 4 premium brands. And this experiment is documented in our next video.
Users can stay engaged and confident in conversations no matter how challenging the environment is. My name is Mariana Vatti, and I'm a senior researcher at Oticon. So personally, I found it remarkable that this study highlighted benefits that have never been demonstrated before. Typically, hearing aids are tested in setups that include noise only from the back. And this is a simple case for directionality because it's geared towards enhancing speech from the front and removing noise from the back. However, in real life, we often have noise from other directions and many times the same direction as the speech. So in this study, we wanted to ensure we have a realistic setup, diffuse, and therefore we played noise both from the back as well as from the front. And this way, we strengthened the relevance of our results to real life. It was extremely rewarding to see Oticon Intent outperform competition in such a realistic setup. We aimed, of course, for a fair and systematic comparison of all the devices, and that is why we conducted the study in a controlled lab environment. So we placed the hearing aids on the head and torso simulator, and we recorded the responses through the ear canals, the amplified sound from the hearing aids. Each device was fitted to the same moderate hearing loss and set to the prescribed settings of the manufacturer. In this way, we can ensure that all the parameters are identical and then the results are comparable across devices. Our study shows that Oticon Intent performs exceptionally well at a range of environment complexities, so from simple to complex and very complex, and when noise comes from the same direction as the speech. Specifically for the very complex situation, we have shown that Oticon Intent can provide up to 45% more access to speech cues compared to 4 leading brands. So this means that hearing aid users can confidently rely on Oticon Intent to provide the necessary support compared to other devices, even in very challenging situations where they cannot turn their back towards the noise, but still would like to communicate.
Right, these results were amazing. So in this study, we document that the Oticon Intent delivered superior speech clarity, providing up to 22% better access to speech cues in complex listening situations against 4 leading competitors. In very complex situations, we see up to 4 dB improvement in speech clarity, leading up to a 45% better access to speech cues than leading competitor brands. In addition, when we presented speech and noise coming from the exact same direction towards the side, Oticon Intent outperformed all 4 leading competitors on speech clarity and access to speech cues, even when it was most challenging. And this is noteworthy because in our setup, the noise and speech are coming from the same direction. So just relying on directionality settings would not be enough to help the user in the scenario because both speech and noise are within the directionality beam. These results show the superiority of the DNN in Oticon Intent and underlines that Oticon Intent pushes the boundaries and can make hearing aid users feel more confident in loud places. So who would like to know who the competitors are? Well, I'm not sharing this confidential information with you. Also, please pay no attention to the colors on the screen. They don't mean anything. When the user enters a challenging situation where positioning themselves to turn away from the noise is not possible, then Oticon Intent will provide the support needed to engage. And this means confidence, both for the user and for the clinician. So with Oticon Intent, users will have optimal conditions to participate naturally. And as a professional, you can feel confident that clients choosing an Oticon Intent have a superior solution in terms of doing well with their hearing aids also while listening becomes challenging. All right, I hope you are now ready and excited to offer this amazing hearing technology to your clients. But if you still need something a little bit extra to sweeten the deal, we're excited to be launching the new smart charger today as well. You now have both the options of a desk charger and a portable smart charger for your Oticon Intent. Both chargers are designed to provide convenient charging and a full day of battery life. And this includes streaming from other devices as well as the use of the DNN and 4D sensors. In other words, the DNN is always active and will not put extra strain on your hearing aid's battery life. The smart charger has the advantage of including the same functionality and benefits as the charger mini, right? With the added features including a power bank and a protective lid. In the case of very large ear molds, the charger may be a better choice. However, please note that the smart charger case will fit most earpieces. So if you do prefer fitting molds instead of domes, or if your client's hearing loss is better accommodated with a mold, you can still select the Oticon Intent and smart charger and are not limited by the type of earpiece or the patient's hearing loss or ear anatomy. In comparison to the previous chargers, the new charger family comes with significant improvements with a focus on reliability, usability, and clinical efficiency. So, following a market wish for faster charging, contact charging technology is used in the new charger, making it possible to provide more than a full day's charge within 2 hours and a super quick recharge in just 15 minutes. That gives you 4 hours of use. So contact charging means faster charging, a smaller charging device, and a more reliable charging experience from Oticon chargers than before. In fact, there is a 33% reduction in charging time compared to an Oticon Real full charge. The contact points on the hearing aids scrape against the springs in the charging port of the charger. And this ensures that any dirt gets removed from the contact points before connection is created for charging, and thereby ensures reliable charging. From a clinical efficiency perspective, it's important to know that hearing aids can be programmed while they are charging in the charger. And this can be especially convenient and efficient considering those times when a client might attend their appointment with a low battery or when a firmware update is needed and where a quick charge can be done during the consultation while the device is in the charger. So when the hearing aids are in the charger, they are on but muted. And this is the reason they can be detected and fitted while being in the charger. And just a quick side note that the Oticon Intent devices must be updated to firmware version 1.0.1 or later for compatibility with the smart charger. Please note that with contact charging, the battery cannot be changed in the clinic, and this is because the battery is fully integrated and soldered into the hardware of the hearing aid, and this offers protection against moisture, sweat, corrosion, and debris. And this means that the battery service must be completed at Oticon. So due to the integrated design of the battery, replacement procedures are more complex and additional service and quality checks must also be performed. So thank you for sharing your time so far. I know I have shared a lot of information, but before we wrap up, I would like to take everyone through the Genie 2 software. We know that our patients will receive the most benefit from our technology if they are well fitted. So in the next video, we will go through Genie 2 before I hand you over to Marika for some exciting announcements. Thank you again, and if anyone has any questions about the information shared today, please do not hesitate to reach out.